So at first, hello, my name is Arthur Lugmayr. I'm from Curtin University in Perth, Western Australia, Australia. And I'm presenting today our latest research work at the FinanceCom workshop 2018 in Manchester. And the paper title is Financial Data Visualization in 3D on Immersive Virtual Reality Displays. And the paper has been written together with Sean Lim, Joshua Hollick, Joyce Khuu, and Felix Chan. I'm very sorry that I could not come today to Manchester because simply it didn't work out anymore with the travel arrangements. But I'm still happy to be somehow present at the conference, and also many greetings to all of you, especially to Fethi Rabi, with whom we have been organizing FinanceCom in 2014. I had no worries. If you should be too bored during the presentation, all of you have been traveling to Manchester. I'm sure at the airplane you got these things, just plug them into your ear. Okay, jokes aside. Basically what we have been doing, and I show a little video clip at the beginning, we tried to do data storytelling. We tried to visualize complex financial data in a little bit a narrative way, in a way that the general public can understand what is going on with financial data. And you see a little bit this clip or this walkthrough through our 3D environment. And our goal was to experiment with new technology, to experiment with immersive technology. And you will see a little bit more how we approach that. And I think one of the things what we achieved, we started to do a little bit data storytelling. We started to add elements there. So just stop this clip now and continue with the presentation. So if you want to see more about my activities, you have the web link here, and the link to my lab is basically here. So basically what we had is we had all sorts of lovely 3D equipment. So we have, in Curtin University, we have the Curtin Hive, which is basically a virtual reality room where we have very large scale screens. We have 3D facilities there. We have all sorts of kind of virtual reality equipment there. And basically we had this. We wanted to do something with financial industries because we found data visualization is still a big problem there. And the good thing is we tried to pull this somehow together. We had a very talented intern student who was working on this application. And the best thing is we had funding available. So therefore we kicked this activity off and we started to work on a little bit prototype or evaluation prototype like software tool. And basically, I want to start with a statement from Nick Beck. Basically, in one of his articles, he told, basically, one of the big problems is the limited screen real estate. So basically, the problem in financial visualization is really we have just limited screens. We stack 2D displays beside each other. We are somehow hidden in this wall behind screens, have all the news stickers there and all sorts of other things. But somehow the problem for us is still the limited screen real estate. And virtual reality could be one of the disruptive technologies which could solve this problem actually. So basically, our starting point was basically how can we advance the way how to visualize data, and we tried to find a couple of red lines what is currently somehow missing in research work. So currently we have a lot of charts. So in financial data analysis or in financial industries, we know we have a lot of charts. These charts are somehow compiled together into dashboards. We have a lot of different indicators inside the charts, candlestick charts, moving average, and all sorts of even more complex indicators. And we have news tickers, but still we have a little bit of problem because there's often there are quite complex dependencies between all the different data entities, and somehow we wanted to experiment somehow how we can reduce the complexity of these. So basically what we wanted to do, we put the human in the center. So we put the human as key in understanding, communicating, and interpreting data, and this despite all these efforts which are done in algorithmic trading and all sorts of things. we wanted to understand, we wanted to explore the possibilities 3D provides in easy understanding of the market situation for increasing the efficiency for understanding this complex information. So we wanted to experiment also a little bit with data storytelling, so because it's a new buzzword in information visualization, which we can put together under serious storytelling, where serious storytelling is a little bit the idea where we use storytelling and narration in outside entertainment contexts. But all these things are now newly emerging and we are not there yet. Basically also what we believed is that the possibilities of 3D and immersive displays is still a little bit poorly explored in financial industries, despite there are quite a few projects which will present at a later stage, but I think they could be done a little bit more. And we also wanted to look into the information design aspect. So what information should be displayed, what are the different ways of communication, what is the accuracy of information, and how can we display or how can we show dynamically changing information. So the project's objectives have been basically exploring, presenting financial market data in a 3D environment. I think I mentioned this quite a few times. Provide a different immersive and engaging experience to the end user. So we wanted to explore different pathways. And we were choosing energy market data as one example for financial visualization because typically it's stock exchange information, you know, and all these things. So we wanted to show it on a little bit a different market segment. And basically, one of our goals was also to make market data understandable for everyone, so not only for the professionals in trading and whatever, so we wanted also to develop a prototype which should be understandable by a regular user. And on the other hand side, it should help regulators, for example, to understand the current market situation, for example, to find out if there have been some trading going on or inside trading and all these things. And as already mentioned, we wanted to explore basic concepts of data storytelling and serious storytelling. And basically, our goal was to develop a prototype to showcase all these possibilities. And we wanted to extract some design guidelines, which other projects can follow, basically if they go in a similar pathway or road. And we wanted to also explore which added value 3D gives in financial markets and how it can support basically efficient and accurate decision making for trading decisions. So in short, we wanted to move from small 2D desktops to large immersive 3D virtual reality screens. And we wanted to move from small display spaces to large virtual spaces in a small physical space. So we wanted to explore a little bit the idea of providing as much information in a small physical space as possible. We wanted to go away from charts and raw data to more analytics and creative data storytelling or creative approaches. We wanted to go away from a low information density on 2D displays to high information densities, because through the third dimension we are able to present even more high information density in a smaller physical space. And we wanted to show a little bit how we can visualize complex relations and more complex data in an easy and understandable creative form. So this was somehow the objectives there. The project outcome was basically an experimental prototype. I know there are still many things opened and we are currently improving our prototype. We are working very hard on following quite a few other research leads now. And we extended the Unity game engine, which is basically a commercially available game engine. We implemented a small 3D charting module for that. We also extended it by a CSV file reading component and electricity data parser module there. And basically, we just wanted to explore the fundamental concept around this one. We wanted to extract, we had developed some design guidelines, and the next sentence is from our internship student, so I'm pretty proud on her because she told it's worldwide the first 3D immersive 3D visualization of energy market data prototype, and I did not find any other one, so let's give her the credits for this sentence. When we look to other projects, there's pretty broad range of projects which have been conducted and done, and you can find them all in the paper actually. So one is Thomson Reuters Acon, so it's a traditional trading desk with some standard 3D features. So it's basically the principle of 3D usage is basically use 3D heat maps, you use 3D plotting, and the interaction is basically via traditional interaction methods and 2D screens. And I mentioned this as a starting point because this is basically the state of the art. Despite there are 3D heat maps and some 3D elements in the trading desks, but it really does not make efficiently use of 3D or virtual reality. I think one very good test prototype is the City Holographic workstation, which is basically an augmented reality workstation for financial trading. And basically what they did is they combined normal 2D displays and added some augmented reality features there. If I can show some of the, I think I have it here, I can show some things what they have been doing. I just open the web browser for that one. Just a second. And that's already quite an interesting approach because they tried really to make efficient use of 3D basically. So, and that's already quite a bit of achievement what they have been doing. I'll just show it. In the background, so this is the prototype here basically. What they did is they developed a trading desk which looks a little bit like that one. So they have traditional charts there, which they said it's still essential to present financial data because it's a very crucial feature in financial markets. But this complete table is basically a complete augmented reality trading desk. So people see this one. So here in the background we can see the physical trading desk out of wood, and then we can see the virtual, the augmented reality on top of it. So here you can see some stock quotes from different things and some different industries and all this stuff. And by using, for example, the HoloLens, you can really make efficient use of your 3D space. So all these are virtual displays, which basically the people wearing the HoloLens can explore, and then there are the traditional charts with normal screens, and then there are the different industries. And on top of it, as far as I remember, there are global markets or specific market segments visualized. So it's a pretty interesting advanced feature from them. Then there are some other ones, trading desk, which look a little bit more future immersive, like for computer gamer which is the Comarch trading desk. There's also another one which uses metaphors like city environments where there are different streets and different buildings which visualizing different stocks, so which is Quant VR. And you see already they go much more further away from the basic simple utilization of 3D elements as part of the complete presentation. They go quite a little bit more into advanced way. We have also, especially the city environment is interesting because they, for example, model tree maps they utilize tree maps, and they model them in a 3D environment. And for example, this is basically placed in a city environment. And for example, each trade is represented by comets. They have ticker tubes and all the sorts of stuff. And basically, they allow typical 3D interaction with the scene there. So you can walk through the city and explore the different stocks. Also, other environments like Invisible, that's one other example there. Just go, Science GL is more a toolbox for visualization and representing data in 3D. Stock city is also pretty interesting because they have a city representation of investor portfolio, so it's a little bit a similar thing like maybe Quant VR, but the city models there represent stock prices, and also like Quant VR, they have the same interaction modality. Then I go a little bit further. There is also some other approaches which are going into similar directions. I want to show you just this, what they have been doing, because what they did is they tried to do is just a second. They tried to bring traditional charting methods like heat maps and all sorts of. Sorry, that was the wrong one. I think it was this one. Just 1 second. Yeah. No, that's the wrong one. I'll show you first what Nirvana Club did. So basically what they did is they had a computer gamer-like environment for data visualization in virtual reality. And they used this environment for visualizing, different, electricity, different, resources like oil, coal, nuclear things, biomass, biofuel. So this is the Canadian energy demand, for example. And they use pretty advanced methods for storytelling, for visualizing charts, how to combine charts, and how to interact with charts. And they use pretty advanced models for basically for this one. I think this is a little bit one which comes most closest to our prototype what we are aiming at. Then what else? Bloomberg Terminal. I think I had the link in the last slide. No. Okay. So then there is Bloomberg Terminal. So that's the normal one, but this allows mostly standard default 3D visualization and all these things. Yeah. And the Nirvana Club normally they had also some. Yeah. Okay. No. So then, so you can look at all this reference work a little bit. You can look through all this reference work in our paper actually. Energy market data. Normally, we selected energy market data because the electricity prices are typically on the rise. It's very difficult to understand for people how the prices come together. All the data is normally freely available, and basically, we wanted to show complex relations between all the data assets, and we wanted to show a little bit a different way of trading what is happening in the energy market. So that was a little bit reason why we looked for them. And normally normally there's the national energy market in Australia is made by one operator, which is the Australian Energy Market Operator, AEMO, and basically he's operating all this. And we have a wholesale electricity market for almost all states, except in Western Australia, the electricity market prices set a little bit different. Typical price setting is done in a supply and demand way. So, and the dispatch price is normally calculated every 5 minutes in 5 minutes intervals, and the spot price is typically calculated all in 13-minute intervals. And basically all transactions are done in basically spot prices. So there's a little bit of lag between the dispatch prices and then the spot prices. And typically it's a schedule, it's very important to understand between schedule demand and schedule generation. So schedule demand is basically a prediction or how much demand is basically guessed, or how much demand there will be, and schedule generation is how much electricity will be generated. So it's a little bit different resources. So basically if the schedule demand is underestimated, then we have a problem with too less electricity. So we need to import certain kind of, we need to import electricity, or we need to increase the local generation. And basically, the demand is basically covered through local, through imports or local generation. The different variables, therefore, what we wanted to visualize is the dispatch price, is the schedule demand, is the schedule generation, and all the net imports, because they're the most important indicators there. We also wanted to visualize the average price per day. We also wanted to show seasonal supply and demand, and also a ratio of renewable energy, especially in the Australian, for the Australian sector. And this is the outcome. You see already we used quite a couple of design guidelines there. So one design guideline which we have been using is coming from an architect, which is basically Kevin Lynch gave some architectural guidelines, for example, how to design a city. So in a city you always have paths, which are streets, for example, then you have edges, which could be like something like which is like let's say the ending of the city, because the city is basically embedded in a river or embedded by the coastline and all these things, or a mountain or whatever. Then we have different districts. So we see the different districts like Northern Territory, Queensland, New South Wales, for example, for Australia. So basically the edge would be here the sea, basically, the Pacific, and this would be the edge from our environment. Then you have different nodes inside the environment, inside the city environment. And in the city you would have landmarks or focus points like churches and all this stuff. And for example, architects apply this in the city environment, but when you look at computer games, they typically apply this when you look, for example, for adventure games and all sorts of stuff, or even for first-person shooter and all sorts of things. You see they use the same architectural guidelines also for marking the boundaries of your environment where you're moving in. Also, we use the second design paradigm, which has been coined by Ben Schneiderman. So it's basically first you get an overview, then afterwards you can zoom in and filter things. Then you get the details on demand, so you get the details when you interact with your environment, and we provide the same guidelines here as well. Then you then you also somehow visualize the relations between the data environments, but you keep a history what the user has been doing, and you can extract certain information. So we also followed these design guidelines, and I will show you a little bit more from the prototype that we have been basically developing, and I will show you which design elements we have been using. So this is our design element. That's basically a virtual fly-through animation through the environment. So basically the paths are the different streets, where you can walk along. Then you have basically already some billboards where you can, for example, see a little bit something what happens. You find also a little bit a help display, for example, when you're walking through the virtual environment. Sometimes it might be a bit difficult to realize, what all the colors mean. So you see, you introduce the user to all the symbolism which has been used, for what coins are used, for what the different light bulbs have been used, and the user itself can walk down these pathways and explore and interact with basically the virtual reality scene. So it's pretty interesting and nice for showing to the end user. I will explain the different elements of this virtual reality scene at a little bit basically at a little bit a later stage. Okay, so you see basically how our virtual model has been working actually. Okay, so the user can explore this, and as you see, it's easy to understand for users who are not in the energy market and how things come together. And this is, for example, the symbolistic for renewable energy versus non-renewable energy. Okay. Then for the symbols what we're using, so of course we use charts. The colors here on a 2D display look very bad because it's a red on a reddish background, but if we tested the different color schemes in a 3D virtual immersive environment, and that work extremely well. So this is our chart. The chart shows the price, it shows the scheduled demand, it shows the scheduled generation. So yellow is scheduled generation, blue is basically scheduled generation. And of course, it's good when the scheduled generation is lower than the scheduled demand, because that's what we want to have, because in electricity markets we cannot have the vice versa case. So for example, all the errors what we see here are green because it's positive for us. So if it would show in the other direction, like here for example, it's a very bad, it's not very good because we need to import electricity or generate more electricity. here we have the symbolism under that. You see a small line here. It's basically the electricity net import. So symbolized by greenish colors means negative net import, which is good. And reddish symbols use a positive net import, and it's red because because we needed to import electricity. Here we see a little bit more information, a complex information desk basically. It symbolizes basically the generation of electricity throughout the seasons, so summer, spring, winter. Despite in Western Australia, more or less, we have only 2 seasons, winter and summer, but we put 2 seasons, but we put 4 seasons there. And one thing is basically the generation. Red means purple, red means low, and purple means high, so we use this as color coding there, this color scheme there. And the demand is basically the intensity of the light. Of course, this is a little bit not so well to show in 2D now. And this is basically the number of windmills tells you the ratio of renewable energy which is produced. Another thing what we used is the coin, which is the average price per day, and we symbolize this one as a coin. And here I again showed again the scheduled electricity demand and generation, just to pinpoint a little bit these red lines here. The system architectures, we used Unity, the game engine. We implemented a simple charting library. We implemented a CSV file reader and the electricity data parser. And we created all the 3D models and prefabs. And we built a small data analytics tool, basically. So basically, as design consideration, I mentioned already most of them. So we used Kevin Lynch's architectural guidelines for city planning. We also developed guidelines for different color palettes and creation for the visualization, creation of the 3D visualization, like contrast, visual clues, for palettes, for gradients, and all this stuff. We also developed a small set of guidelines for the use of symbols and semiotics of different 3D models, which are then used to illustrate the essentials for the data, like objects, colors, positive, negative events, ratios, sessional differences. We migrated also 2 charts into a 3D environment and developed some design guidelines around this one, and especially how to provide additional information inside this chart, because we have simply more space. We have a larger virtual reality space. We also included Ben Schneiderman's overview, zoom, filter, details on demand, relate, history, extract design guidelines in this one. And what we found out is basically we can present in 3D. For example, when you look through the charts, within a simple chart, we can present a larger amount of information with simply a more limited space. We also can overcome space limitations due to restricted physical space, because trading desks are simply small, and with this one we can overcome the physical space. We can add much more data which provide meaningful additions of information through the actual visualization into this one. And it's easier, we are supporting basically human cognitive functions, like, for example, pre-attentive processing. So while we are exploring something, our eyes are all the time saccading through to find something new what we need to explore, and 3D environments support this pre-attentive processing tremendously. It also allows us easier information and knowledge discovery, and it's simply more visual appealing presentation, especially when we look for qualitative and quantitative data, and especially if it's targeted towards, the general public rather than only, people which are in the financial industries. And we can really present very complex data in a very simplified way. But I think the most important thing is, and this is a little bit to the opening statement what I was having at the beginning of the presentation, and what I had all the time the feelings, financial industries, employees, traders, they are really crazy about charts, getting all information presented, tickers, they are crazy about new alerts, they are crazy about new displays. And why don't we simply provide them, fulfill their user demand, and provide them with even more information in virtual reality? So this is somehow a little bit this thing. Of course, we have quite a lot of work still to do. And we work especially with this idea of cognitive big data. So how can we understand data better data, and how can 3D visualization ease the understanding and ease our cognitive efforts to understand data, so which we coined a little bit as this cognitive big data during the last years of research. We also want to have a full real-time display in immersive environment. We want to do user testing. We also want to do advanced methods for storytelling, especially, for example, how prices are set, how the bidding processes are done, and how can our order book and electricity market be done. And of course, we work, how can we increase even the data amount there in this display? So how can we add more parameters of electricity data there? So that's a little bit our future work. So I would like to thank you for listening. If you want to see more about myself, if you want to contact me, you have my email address here. So it's a nice email domain which I have been buying. So firstname.secondname@firstname-secondname.com. If you, after sending me an email, if you still should not be able to type or spell my name, you type in simply my web link, and then you see more information about me. But I also want to emphasize, so we still have a call for book chapters there for our new serious storytelling handbook, so where we also look for data storytelling and for serious storytelling. So how can we use storytelling and narrative outside the entertainment context, like in healthcare, e-education, for financial trading. And the call for book chapters is still out, so you can still submit a chapter there. So just go to www.outdoor-lugmayr.com and you find the call for papers there. You're just calling for abstracts at this stage, so you can submit, I think it's 300 words or 400 words abstracts there, and deadline, I think it was 30th of June, so just submit it there. There will be a second call out for the final chapters then. Then also, if you're interested in publishing a book series, I established a new book series which is called Emerging Media Technology and User Experience Computation, in short EMO. EMO because that's one of the famous Australian animals, you know, these big birds and all these things. And basically, if you want to publish textbooks, monographs, or handbooks, please just come in touch with me. If you cannot spell my second name 2 times, then simply go to my website and click email. That's easier. I still would like to acknowledge Curtin's Hive and its team, so namely Andrew Woods, for all his help for establishing all the projects in the Hive. I also would like to thank Curtin Institute for Computation for the financial grant, for the grant which we got for the development project, and also for the all other help and support during the past years, basically. And here you can find all the references, most probably not readable, but simply you can find them also in the publication. Okay, so thanks for listening, and I hope it brought a little bit some new ideas towards how data can be presented in financial markets.